Hi, welcome to another Level 1 Tables, Equations and Graphs videos. We continue exploring linear functions, and in this video we're going to chat about the applications. So we know most straight line graphs can be written in the form y equal to mx plus c. Let's get straight into example 1. This is an example which has on the x-axis distance in kilometers, going up 1, 2, 3, 4, 5 kilometers and so on. And on the y-axis, we have the charge, the amount somebody charges somebody for a service, like a taxi driver or something. And that's going up, well, the big number's going up in tens, but you can see there are smaller bulk units going up in twos. Right, let's take 2 points on the graph, the starting point and another point on the grid, and let's work out the gradient first. To do that, we need to work out its rise. So if we can work out where it starts, 2, 4, 6, so it starts at 6 on the y-axis, and the second point we're using is at the point 34. So to work out the rise, we need to go 34 minus 6, which is 28. So it's risen up 28, and it's run along 8 squares, or 8 kilometers. So to work out the gradient, or we could call it the rate of change, we go rise over run. The rise we've worked out is 28, the run is 8, so 28 divided by 8 gives us 3.5. Now, because this is to do with money over distance in kilometers, we're going to say $3.50 per kilometer. So if maybe it was a taxi service, they charge $3.50 per kilometer. Right, so let's go back to y equals mx plus c. We've just worked out what m is. M is the gradient. And we know the gradient is 3.5, $3.50. C, remember, is the y-intercept, where the graph crosses over the y-axis, and we know this crosses over the y-axis at positive 6, so that's why we have plus 6 for C. So we have a formula y equal to 3.5x plus 6. However, because this is to do with real-life scenarios, not y's and x's, we're going to do the following. We're going to take charge, which we're going to call c, and replace that for the y, c for charge, and we're going to take the distance, which we're going to call d, and replace that with x. So we're going to write down our formula as the charge c is equal to 3.5d plus 6. Some people prefer to write it as full sentence. Charge is equal to 3.5 times distance plus 6. Right, let's get into example 2. Here's a plumber who charges $45 per hour plus a one-off travelling fee of $50. So we're going to do a quick table and work out some costs based on a couple of hours. So here's some hours. I'll pick 0 through to 4. And let's start with 1 hour. If he does 1 hour of $45 plus the $50 travelling fee, which is $95. 2 hours, 2 times 45 plus the 1 hour plus the $50 fee, which is $140. 3 hours, so that's 3 times the 45 plus the $50 travelling fee, $185. 4 hours gives us $230. And even though it doesn't make much sense, 0 hours, which would mean 0 charges, 0 times 45 plus the $50 fee, which would just give us 50. So let's plot these points on the graph and draw a straight line graph between them. Right, well now we're going to work out what the formula y equal to mx plus c is. So we know the gradient is 45. We could work out the gradient by working out how much it rises by how much it runs. The way we did it in the last example, we take 140 minus 95 to get the to get the rise, 140 minus 95. And then we go 2 hours minus 1 hour to get the run. But I'm just hoping you can see very quickly that if it's $45 per hour, that means every 1 hour we charge 45. So it goes up 45 and across 1 hour. So the gradient is 45. The y-intercept is 50, passes through 50. That's that one-off travel fee when we have 0 hours. So our formula y equal to 45x plus 50. Now again, this is a application, so we're going to replace the y with c for charge, and we're going to replace the x with h that represents hours. So the formula c is equal to 45h plus 50. Right, well that's us for this video, so thanks very much for watching in.